So let's continue with our hypothesis tests. At some point, we're going to have to perform a statistical test to decide what do we think is true, HO or HA, the null hypothesis or the alternative. So we're going to have to make a decision regarding the null hypothesis. And our decision is going to be to reject the null hypothesis if our p-value is less than alpha. Now, as a reminder, alpha is your level of significance. Level of significance. Typically speaking, that value of alpha will be given to you. But if your p-value is less than that value of alpha, then you're going to reject H naught. What if it's greater than alpha? Then you're going to fail to reject H naught. Now you might notice I don't have a greater than or equal to. If it actually landed on this, I suppose you could choose whichever one you want. The nice thing about the p-value is that it lets whoever reads your work decide where they want to put it themselves. So, but I've never actually seen it equal there, except in contrived examples in books. Typically, your value of alpha is 0.05 or 0.01. Those values are going to be given to you. You're not going to have to just decide, well, what should alpha be? That's going to be something given to you. Those are your typical ones. Occasionally, you'll see things like 0.1, but I don't think that's really that great of an idea. Now, because it's kind of important that you keep these things straight, the author has a couple of mnemonics for you. The first one I like, the second one I don't. I'm going to give both to you because I think both of them tend to show up in the homework. If the p-value is low, H naught must go. In other words, reject H naught if you get a low p-value, lower than alpha. Okay. The second one, if the p-value is high, H naught will fly. If the p-value is high, H naught will fly. Okay, great. Those are the two little mnemonics. Like I said, I'm not too fond of that second one. But just keep in mind that if the p-value is lower than alpha, p-value is lower than that 0.05 or 0.01 value, that you're going to reject. The smaller the p-value is, the more likely you are to reject H naught. One more comment about p-values and things like that. We haven't done type 1 and type 2 error. I'll hold off until we do type 1 and type 2 error. So let's flip our papers over then and take a look at the next little piece. And I got to grab one. So let's see if we can't figure out a little bit about p-values here. Which one of the following is not true about p-values in hypothesis testing? Choose the correct answer below. Is the p-value an area?
Yeah. No.
You gotta pick one. Yes or no? Is the p-value an area?
Yes.
Yeah. We always found the p-value by. I didn't say no.
No, she said no. I said yes.
All right. One of you is a ventriloquist. So that one's not the right one. If the p-value is high, the null will fly. All right, we do that one. We did both of these. The one that doesn't fit, and part of the reason I'm going through this one is because you're going to see this one in your homework, is this one. This kind of comes close to what's called the classical approach of hypothesis testing. We haven't talked about critical values at all yet, and it's just not right in this context. So this is the one that you should circle. That's the one that's just wrong. Now, let's do some testing of p-values. And I'm going to do it like this. Actually, you know what? Let's see. I might have Let me flip it over here real quick. Yeah, let's just do it this way. So, we're going to look at some p-values and alpha combinations and make a decision. So we're going to look at our p-value, alpha, and decision. So for our p-value, let's look at 0.049 and 0.003, 0.051, and 0.137, and look at corresponding values of alpha. So alpha 0.005, that's a very typical value. Alpha 0.01, that's another common value for alpha. Let's stick with 0.01, and we'll go back to 0.05 here. Now sometimes, depending on you and depending on the circumstances, you might want to put in an extra character just so that you can look at things and compare them a little bit easier. It doesn't hurt to put on a 0 in each of these. That way you might be able to look at this and say, oh, well, this is 137, this is 50. 137 is more than 50. And then give me your decision. So your decision is either going to be fail to reject H0 or reject H0. And I'll give you a minute or two to look at that. Try and work your way down that. Decide what you think is what. There's a good reason for that, and I really appreciate the question. We'll talk about that and the reason for it. Little disagreement over there? Little oops.
Don't come over here. Don't come.
But if I don't come over here, then you go, check mine.
You never come
So
over
I always,
here, so it's no point.
damn if I do and
You
damn if I
had
don't.
just skipped us anyway.
Right.
You only came back because you heard us disagree.
What's that?
These two would be rejected now.
I think.
Alpha is great.
Would they?
Okay, you can check mine. Can you check it? Because I think until this wrong. Hold on now. Am I wrong?
You're wrong.
Okay. Never mind.
Maybe not entirely, but at least one. How about that? At least one is wrong.
Oh.
Maybe go back to this at least. Oh my gosh.
At least one.
At least one.
Alpha is
At most four.
At most.
Yeah.
Hate it
I
here.
know. I looked at alpha squared. P-value.
Okay. What is alpha?
So let's take a look here.
So at least one is right, is what you're saying. Or one is wrong.
If the p-value is low, reject H0. Now I had a really good question here. Why are we using this peculiar terminology of reject H0 and fail to reject H0? Well, let me remind you, or basically probably tell you, something that is true about these decisions. When you're making these decisions, let's see, H naught is assumed true. And HA, that's the alternative. It's what's true if we reject H naught. It is true when we reject H naught. So in a lot of ways, it's like a jury trial. You're presumed innocent until proven guilty. So you got to have enough evidence to reject H naught before you can conclude that, yeah, we think he's guilty, or we think that the alternative hypothesis is true. So the fact that you can't reject H naught doesn't mean that it's true any more than coming out of a jury trial proved you're innocent. No, you just weren't found guilty. It's not saying you were guilty, you just weren't found guilty. So here it's assumed true until proven guilty, assumed true until proved otherwise. So when you're talking about your null and alternative hypothesis and your decision, it's either reject H naught or fail reject H naught. I used to say accept, and then I changed that because you're assuming this is true. And saying accept it almost feels like you're saying that we think it's true. We don't know if it's true or not. We just didn't prove that it was false. So let's take a look at our decisions. Let's run it around the room a little bit. Ryan, how about the first one? What do you think's true here? What was our decision going to be? Yeah, you're going to reject H naught. This is smaller than this, so you're going to reject it. Now, was it close? Yeah, absolutely. You got to look at it kind of carefully, but you're going to reject.
Can you put the signs there? That
Oh.
was greater than 30.
P-value, all right, yeah, good idea. P-value is less than alpha, so you reject. Nice. How about the next one? Reject or fail to reject? Reject. Good. So once again, this is smaller, so you're going to reject H naught. How about this next one? Reject or fail to reject? Fail to reject. Good. This is greater than this. In fact, that's true in the last two of these. So you're going to fail to reject in both cases. Fail to reject and fail to reject. I would ask that in addition to fail to reject, you say fail to reject H naught, because sometimes people get confused and think they're rejecting HA. And it leaves me a little bit uneasy if you just say fail to reject. I know it feels like H naught is implicit in this. Maybe it is, but make me happy and write that H naught there. Now, there's a couple things that can happen when you're doing a hypothesis test. And so we're going to get into the different types of errors and their consequences. And that's where we're going to finish things up today. We'll actually do the hypothesis test itself, starting with the material in section 8.2. I'm going to draw myself a little box. This is going to be a little 2x2 box of the different things that can happen when we start looking at a hypothesis test. Here. Leave yourself a fair amount of room here. Let's see. There. It doesn't have to be perfect. Now, when you perform a hypothesis test, you don't know what's actually going on with H naught. Just like a jury trial, you don't know if the defendant is innocent or guilty. You're just going to look at the facts and make your best decision. So H naught is, in fact, it could be true, it could be false. We don't know which. But we are going to have to make a decision based on some statistical evidence, based on some data. Now we have a couple different choices. we could fail to reject H naught, and we can reject H naught. And what I invite you to do now, or even if you're watching this later on video, is to pause things and decide, well, where are the correct decisions? Or maybe there's only one, maybe there's none. What do you think? What are the correct decisions in this setup? What would be a correct decision based on your combination of HO is true or false and then our decision? What constitutes a correct decision? Work through the possibilities. If H naught is true, should we reject it? No. So if we fail to reject H naught when it's true, is that a correct decision or no? Yeah. I got one voice and 20-some that are unsure.
Can you repeat what you just said?
So let's assume that H naught is true. Independent of H naught being true, we look at our data and we decide, oh, you know what, we're going to fail to reject H naught. That means we're not rejecting H naught, that H naught is what we believe is true. So this would be a correct decision. Yeah, decision. Because we're not rejecting H naught. H naught is true, we didn't reject it, so that's a correct decision. Find the other correct decision. What else is a correct decision in this? I got a false and we reject it. All right, a couple nods on that one. That one's also a correct decision. Now, very creatively, we came up with a name for this kind of an error. Ready for this? It's really creative. It's called a type 1 error. Even more astoundingly is what we labeled this other one. Anyone want to guess that one? Type 2 error. Yeah. Woohoo! Type 2 error. Wow. So several things can happen when you're doing a hypothesis test. You can make a correct decision, or you can make a type 1 and type 2 error. Our goal in the time that we have remaining is to try and understand what these are and put them into words relating to the problem. That's going to be a little bit more challenging than it may sound. So let's see here. Now, before I go through examples like that, let me mention something related to this. The probability of a type 1 error is something that you're familiar with. It's alpha. Something you can actually control. This is your level of significance. That's stuff that we use when we're creating confidence intervals. So it's something that's familiar. And again, in a burst of creative thought, probability of a type 1 error is alpha. Probability of a type 2 is beta. There you go. Now, beta is not something we're familiar with. This is expressing the what's called power of the test. You'd really like both of these to be pretty small. We're not going to really be able to directly control beta in this course. This goes a little bit beyond this course, but we are going to work with alpha. You can control alpha. You don't want to make alpha 0, otherwise you wouldn't ever be rejecting a null hypothesis. But you can make it appropriately small depending on what are the consequences of a type 1 error. What does it mean to be wrong? So, you know, what I think about a lot when I'm biking in the morning with a bunch of my buddies is a lot of times they'll call out, you know, as we go to an intersection that, hey, there's a car here. To me, you know, I think you should leave that decision to people who are actually there. I think you should each make your own decision, because if you call out there's a car there, or if you call it there's clear there, you could make a mistake. If you call out it's clear and it's not clear, that could be a serious mistake. If you call out it's not, or if you call out it's not clear and it actually is clear, the consequences there are less severe. But the consequences of an error can be pretty drastic depending on, you know, what the situation is. So you want to be aware of what does it mean to make a type 1 and a type 2 error. All right. Let's look at a couple examples. And let me show you what I'm looking for when you state your type 1 and type 2 errors. So in stating in words type 1 and type 2 errors, type 2 errors, I'm looking for two things. First of all, state the condition of H naught. Is it true or is it false? State the condition of H naught. Is it true or false? Should be here. And second, state what you decided. State what your decision was. It's either reject H naught or fail to reject H naught, but I want you to state this in words. And I should probably put a little asterisk up here. These have to be words that relate to the problem. Words that relate to the problem without using heavily laden terms like parameter or hypothesis. Words that relate to the problem. Do not use parameters or definitions. I will literally give you the definition of a type 1 and type 2 error on the test. I'll just give it to you. So when I ask you these types of questions, if you give me a definition back, I'm just going to mark it wrong because I've already given you the definition. I want you to show me you can put this into words related to the problem. So let's look at a few examples as much as we can from example G here. And that's going to start out with the proportion of people who write with their left hands is equal to 0.1. Now Barack Obama and I think 5 out of the 6 presidents, including Barack Obama moving back, were left-handers, which is an unusually high proportion of left-handers. But let's see what that says. What does a type 1 and type 2 error mean in this case? Now to get started, we're going to start with writing down the null and alternative hypothesis that go with this. That's where we're going to need to begin. So example G. And it says kind of problem 25 here, so I'll put that there. The proportion of people who write with their left hand is equal to 0.1. So there's a few things that we'd have to get out of this. First of all is the parameter that we're working with. It's a proportion. Is equal to 0.1. So that much tells us that P equals 0.1. Great. What hypothesis does that go into? Me? P equals 0.1. What hypothesis does that go into? HA? Ooh. It has the possibility of equality, so it has to go into HO. So P equals 0.1. Now, if that's our null hypothesis, what's the alternative hypothesis? P is not equal to 0.1. Great. So we have to get that straight before we start our type 1 and type 2 errors. Now our type 1 error, let's understand what that's saying. H naught is true, but it gets rejected. So I want you to state those two things one at a time. State what's the condition of H naught so that it's true, and then state what your decision was. And all of this should be related into the original problem. So a type 1 error is going to look like this. While it is true that 10% of people are left-handed, so what am I doing here? I'm stating what's true about H naught, or the condition of H naught. It's true. So while it's true that 10% of the people are left-handed, the data reject that claim. So that's stating what our decision was in the face of this right here. Notice that these things don't match, right? They shouldn't. We've made an error. These shouldn't match. These shouldn't be the same. So it's true that this, 10% of people are left-handed, but the data reject that claim. We concluded HA when we should have concluded H naught. That's why we made a type 1 error. How about a type 2 error? Well, let's understand or remind ourselves what a type 2 error is. I mean, this stuff is pretty fresh. Type 2 error, H naught is false. And even though it's false, our data don't lead us to reject that claim. So meaning, well, we can't say that it's false because we don't have enough evidence, so we're just going to accept it. That's really what's happening in that case. So here's an example of what you can say. While it is, I was going to say not true, or while it is false. While it's not true that 10% of people are left-handed, so again, you're stating what's the condition of HO? It's false. You're just stating that in words. Now, what was our decision? It's false, but did we reject it? No. But the data failed to reject that claim. All right, so again, it's got the two things that I'm looking for. It tells me what's the condition of H naught, and it's going to tell me what I decided compared to that. These things should not match. It's not true, and even though it's not true, we didn't reject it. We should have, but we didn't. That's why we made an error. These things are hard to do and even harder to grade. I really am not a fan of these, but they're important. You need to understand the consequences of making a wrong decision, and those consequences weigh into your choice of alpha. Let's try one more. Comments on this? Does anyone want to try their version, or I think you're probably at this point you're just copying down what I wrote, but I want to give you a chance to do your own in the next one. So we're sticking with proportions in this. The proportion of people who know that Jeff Perrin is an awesome stat instructor is at least 84. Oh, I'm sorry, I misread something. Yeah, the proportion of people who know that water boils at a lower temperature at high altitudes is 0.34. I think that sounds kind of low. I think more people know that, but whatever. So the proportion, let's start with our original claim. Proportion is equal to 0.34. Okay. So in terms of symbols, that's going to be P equals 0.34. This next one, if you're interested in looking at that next one, maybe sometime at home, here P is greater than 0.25. I would definitely say that one's true. P is greater than 0.25, at least based on my own experience. Proportion of job interviews that result from an online application is less than 1/2. So that'd be P is less than 1/2. So there'd be all your statements. Those first two are going to be part of the null hypothesis. The second two are going to be part of the alternative hypothesis. Let's set up HO and HA for this one. So this one's 26. Our original claim was that P is equal to 0.34. That's going to go here. The alternative is that it's not equal to 0.34. And now I want to state a type 1 and type 2 error. Type 2, not type 3. There's no type 3. Give yourself a minute to try and, or so, thereabouts, to try and fill that one in. Try and decide. State two things. What's true? And what did you decide in comparison?
What? Rejecting.
Oh.
Don't play.
Yeah, that worked.
Thank you.
Yeah, that's a nice way. So I'm going to ask for some volunteers to share when they got. That'd be a good one.
How you know? Because she came in before I left. And she
Well,
went to
you
lunch.
want to keep them in mind when you're doing these hypothesis tests, so that you're conscious of the fact
I was about to
that
ask,
you could be
did
wrong.
your class
I
counters
mean,
for break?
our judicial system is set up in such a way that, yeah, there's two mistakes we can make. We can send a guilty person to jail, or we can send an
You could be eating.
innocent person to jail, or
But you
we
ate
can send a
everything.
guilty person
That's
free.
true, I did.
Of those two,
You ate
the worst
everything before
one
you even walked out the
is
house.
to send an innocent person to jail. So that's why we're
Sound like
innocent
the
until
people that be like,
proven
I
guilty.
made my meal prep
It's
and
because
I ate it all
we
in
really
one
want to
day.
be sure we get this right. So we're weighing the consequences of a wrong decision. And that's what a type 1 and type 2
That
error
would
is
be
making
delicious.
you cognizant of
Gone in
as
2
well.
days.
What's the consequences
Yeah,
of
that's the
being
Barbie
wrong?
problem.
So, I mean, I want to talk about that in the context of global warming. I mean, there's a couple decisions we can make about global warming depending on if you think
Fuck no. I get it. Yeah, this name is the delivery.
mankind is
Okay,
the
I'll pay it this
cause
much.
of it.
Because I
You
wasted
can
this
say,
gas.
yeah, we're the cause, and do a lot of work to try and correct it, only to find out, oh, we're not the cause. And then we spend a lot of money, a lot of time, and people say that, oh, we lose jobs. Well, if you accept all that, that's fine. There's still some consequences. Or you could be wrong in another way. We could say, no, it's not really us. And then we don't do anything, and then we turn planet Earth into a raisin, and we become like Venus, and then we're really obvious. Yes. Rejects the hypothesis in words. In this case, rejects the idea that 34% of people know that oils and barrels. But don't use null hypothesis in your answer at all. Don't use symbols, just words.
You say because he's so stupid.
Yes. What do you got? let's finish this up. So there's a couple. There's a variety of ways you can answer this. You don't have to just exactly copy what I do, but you know, if you want to be comfortable doing that, that's fine. Let's see. Someone want to share theirs? I want yours second. Let's do the generic one that I would write first. Well, who's got something similar to that? While it is, yeah, true that 34% of people yeah, this is yeah, thank you. I was going to say, you don't have to write it in your notes, but make sure you write it in the test, because I'm going to want to see that. So, while it's true that 34% of people know that water boils at lower temperatures at high pressure, or at high altitude, then what happens? So that's what's true. What happens? The data reject that claim. Now, Matilda had a different way to say that, and it's equally valid. So what was yours, Matilda?
Rejecting that 34% of people know that water boils at lower temps of high altitude when in fact it is true.
Okay. So rejecting the fact that 34% of people know that water boils at lower temperatures at high altitude when in fact that claim is true. Perfect. It's saying the same two things in just a little bit different way. And because I sense you guys are anxious to leave, although that hurts me.
I'm still ready for type 2.
Yeah, okay, that's good. So type 2. So while it is not true that 34% of people know that water boils at lower temperatures at high altitude, then what? So that's what's the status of H naught. It's not true. And all you're saying is saying H naught is not true in words. The data fails to reject that claim. Fails to reject that claim. It's just good to know what's true and false about these things so that you can keep in mind, you know, what you want to do as far as a level of alpha, and understanding the consequences of getting it wrong when you do your statistical test. We can't prove things in a math class. We just don't know. We make our best guess, but, you know, hey, things go wrong. So you have to be aware of what can go wrong and what does it mean. So these are a good 8-point problem on an exam. So do 8s, 4 for each part. All right, so make sure that you spend some time with them. And I've got other videos available to go over some more of these things. All right, have a good one and see ya.